Screencast AP Chemistry 2.13 Solubility Rules. If we lived on a dry planet such as Mars or a moon such as the Moon, which by the way both have water but not in liquid form, hence the term dry, we wouldn't be so concerned about aqueous solubility. But we live on a very wet planet and we are very wet beings, and so what dissolves in water is really an essential part of everything for us. So chemists devote a lot of time to it. This screencast is devoted towards what dissolves in water. Most of it is actually, for this slide, memorization. We can go into some of the reasons solvation and a molecular look at it another time, but for now we'll just determine what it is and which are and which aren't soluble. Solubility is what dissolves in water, something that will dissolve in water, but let's be more specific. Let's talk about to what extent, and that's dependent on things such as temperature. So we'll define it as the maximum amount of solute, that's the stuff that's getting dissolved. It's by definition the minor component, that will dissolve in a given quantity of a solvent at a specific temperature. So it's something you can look up in a table. Here's some rules. They are rules without explanations. Some things are always soluble. For example, the group 1 ions and the other group 1 cation that is not monatomic, being the ammonium cation. So all the group 1 ions, there they are, lithium through cesium, as well as the ammonium cation. The halides are always soluble. But look at fluorine is not there. That must get treated separately. Nitrates are always soluble. Bicarbonates are surprisingly always soluble. Chlorates are always soluble. Perchlorates are always soluble. Pure memorization. Some exceptions to those three halides include silver, mercury 2, and lead 2+. Those are ones, frankly, I always forget. I would recommend that you take a quick look at them the night before the test, because talk about obscure. Sulfates are generally soluble. That's something to know in general. It's easy to forget. Exceptions include all sorts of things, and there's the list. Memorize that before the test, but don't expect to hold that in your head. Although some of these just seem to just scream insoluble. Something about lead is always insoluble. Silver, things like that. Okay, it's very picky. Insoluble compound. What can we say about things that are always insoluble? Maybe group 2s? No? No. How about this? Carbonates. Phosphates. Isn't that interesting? Phosphates are usually insoluble, but sulfates are usually soluble. Chromates. Sulfides. However, if it happens to be an alkali metal as the cation, that's an exception. Now that really doesn't need to be mentioned because there's no exceptions to this anyhow, right? So if you see that in the front, end of story. You don't care about that. So this doesn't really need to be stated that much. Hydroxides are surprisingly insoluble, even though those are the basic form of a base, if you will. There is an important exception. Barium hydroxide is largely insoluble. Don't forget also that somebody had to decide what is soluble and what is insoluble. What if it's 1 part per million soluble? What do you go with? I'm not sure exactly where the dividing line is, but they had to pick something. Once again, we wrote the alkali metal ions, so we didn't need to. This should be enough information for us to make some guesses. Now I'll go ahead with my non-pure memorized knowledge of this and show you how I would do these. Sodium hydroxide, group 1, doesn't matter that hydroxides are generally insoluble, so that is soluble. Sodium carbonate, group 1, always soluble. Silver, it's kind of insoluble, but wait a minute, nitrate, always soluble. Nitrate, always soluble. Sulfates, they're the ones that are generally insoluble. Wait a minute, sodium, always soluble. Calcium and sulfate. Sulfates are generally insoluble. Bang, bang, bang. I had to cheat. It's an exception. Calcium sulfate is insoluble. Calcium carbonate chalk. I believe that's insoluble. We do a reaction where we precipitate it out of solution. So there's a good example of where you physically watch it. You're unlikely to ever forget things when you see them in the lab. personal aside, I've been a chemist for a long time, and I'm always shocked at how much what I truly remember is that which I actually witnessed, because that seems to trump just about anything, right? So calcium carbonate, insoluble. Ammonium, always soluble, so that's into that. Ammonium, always soluble. These weren't so hard. They didn't throw a lot of the weird exceptions in here. And so that's a little bit about solubility.